let's write another method that will recurse over strings. So we're going to write a method called swap AB that when we give it a string, it's going to recursively swap all occurrences of AB with BA respectively. So let's see what the tests look like. So we have a bunch of tests here. We have some strings that we have a string that's empty, which just gets us back the empty string. A string of only one character obviously doesn't have any ABs in it. But then here we say we have the string AB, it gets us back BA. Now notice that our method is not going to be case sensitive, because if it contains the lowercase letters AB, or even if only one of them is uppercase, then we're just going to return the original string. So it would be a good exercise for you all to try and write this method such that it doesn't take case into account. Meaning that this test case would produce, for example, BA, this test case would produce uppercase B, lowercase a, and this test case would produce uppercase or lowercase b, uppercase a. Okay, so that'd be a good challenge for you all to try. Now, if the string does not contain the substring AB, then we just get the string back, right? But any other occurrences of AB are recursively swapped. Now, how are we going to do this? So, the idea is actually pretty straightforward. We're first going to check to see if the string does not contain the string AB. So that's our base case, okay? So if it doesn't contain AB, then there's nothing to swap, so we're just going to return the string itself. Notice that doing that handles multiple cases in one. It handles the empty string, it handles the strings of only one character, it handles any string that doesn't contain AB as a substring. Okay, so let's first do that. Let's say if it's not the case that S contains AB, then just return S, because there's nothing left to do. Okay? Otherwise, then so remember what's true when we're inside this block. It's really important to always understand what holds true when we're inside the else block of some condition. If this case were false, if S does not contain AB, then we would be in this block. But if, in order for us to be in this block, S absolutely has to contain AB somewhere in the string. So, remember the property of strings though. Strings are immutable, so we can't change this string. But we can return a new string with the property that we so desire. And the property that we so desire is the substring AB swapped to BBA, or to become BA. Sorry, I don't want to confuse anyone out there. Okay? But how are we going to do that? Let's take a string just for example. So if we're in that else block, then we have some string, let's say W. So that means our string S is some string where we have a component W, we have an A and a B, and then we have another component X, where either of these can be the empty string. So for example, if we have the string C, A, B, D, E, what are our A and B components? Well, or sorry, our W and X components. This is going to be our W, this is going to be our X. Okay? Now, hopefully you can see why it's impossible for the way we're going to implement this, or sorry, it's not obvious yet, but the way we're going to implement this is that it's going to be impossible for W to contain an instance of AB. Because if it did, so let's back up one more time and talk about how we're going to implement this. What we're going to do is we're going to find the index of the first occurrence of this substring. So if there were an occurrence of AB before this one, the one that we get, then it would contradict this, because then this would not be the first one in the string. Okay? So if that doesn't make sense to you, let's check out another string. So we have the string, let's say, C, B, A, B, D, A, B, A. So what's our W and what's our X? Well, we see that this is the first occurrence, So that means the first occurrence of AB is at index 3. Then our W, let's make it a different color. Our W is going to be this, excuse me, this part is going to be our X. Now notice that in X, there certainly can be another occurrence of AB. But we don't care about that at this point in the recursive call. Because what we're going to do is we're going to take this string, we're going to take our W, okay, so we're going to take W, we're going to take the AB, and we're just going to flip it. We're just going to say plus BA, and then plus, we're going to recursively call on X. Okay? So there's no reason to recursively call on these because there's no possible way that AB could be in this string. Okay? Because if it were, then again, that would contradict the fact that this occurrence of AB is the first one that we find by using index of. Okay? And then we'll handle the X case recursively. So when we handle X, what is our W and what's our X? And we'll just call those W prime and X prime just for simplicity. So then we do the same thing. We're going to return W prime plus BA plus recursively call of X. Okay. Then when we get down to this occurrence of, so this would be X prime, sorry. And let me also, let's make this a little bit, there we go. Okay. So when we get down to the X prime, we see that X prime is just one character. And more importantly, however, there's no occurrence of AB in this substring, so we just return the substring itself. Okay? So let's go to our code. Now, let's make variables for those components. So we have the component W, and what is that going to be? That's going to be defined as, so let's first off find the position of AB by doing s.index of, and then AB. Okay? So again, in order for this code to not return -1, or rather, if this code were to return -1, then like it's not possible for this to return -1. Because if it would, then .contains would have failed, right? Because in order for something to not contain something, then there can be no index of that string. Okay? So if that doesn't make sense to you, try and think about... My cat is sneezing, I am sorry. Try and think about how to write .contains in terms of index of. Okay? So here, let's say that our W is equal to, so if we go back to our diagram, we'll see that W is actually index 0 up to the index of, and actually this would be 2 and not 3. That's my bad. So we would just do the substring of S from 0 up to the position. Okay, and then what would X be? X would be the position plus 2, right? Because we skip over this one, and then we're just going to start back on this substring, and we're going to recurse on that position up to the end of the string. Okay? So even if that's the empty string, it's fine, and it will work just as expected. Okay? So s.substring of 0 to pos AB, string x is equal to substring of pos AB plus 2, and then just return W plus BA plus swap AB on X. Okay? And we test, and to our delight, all tests pass. Okay? So this is a really good problem, and I do encourage everyone to try the problem of making it sort of like make it so that if this were case, like make it case insensitive. An even bigger challenge would be to try and make it like swap and you give it a string, and then when you so like instead of being just AB, what if we wanted to pass it a string like BC, and then if we find an occurrence of BC, we replace it with CB. Okay? That would be a really good challenge for you all to try. So to get you started, you could do something like static string swap chars. You can give it a string S and then a string, the swap string. And then just you could do some things here. So, but for now, I'll just return null. But the way we would call this is by something like this. Then we have an assert all, and I just want to copy this just for convenience. So we could call it by doing swap chars, and then we could give it like ABA abacab, and then pass AB, and then this would return BAA CBA. Okay? But if we passed it CA, then it would return AB ACB. Okay? So, of course, those tests won't pass right now, but if you have time, try and solve that. That'd be a good challenge. And if you can always ask and let us know, and we'll tell you if you're correct or not.